In this video, we're going to talk about the first of our AP reaction types, which is precipitation. Basically, all of the 5 different reaction types that you guys learned sophomore year, synthesis, decomposition, single replacement, double replacement, and combustion, can be categorized as one of 3 types of reactions when it comes to writing equations. We call them precipitation, redox, which is oxidation reduction, and acid-base. Right, so we're going to learn how to write net ionic equations for all these reactions. So our ultimate goal here is to get you to identify whether or not a reaction is precipitation, acid, base, or redox. Precipitation, usually we're going to use the solubility rules to help us write net ionic equations. So you have to have the solubility rules memorized in order to be able to do this. And for all of the reactions in this video, or for the reaction in this video I should say, we're going to be using the reaction between lead nitrate and potassium iodide. Alright, so we should probably start off by defining what a precipitation reaction is. A precipitation reaction is just a double replacement reaction that produces one non-aqueous product. Usually that product is going to be a solid, and both of the reactants are usually going to be soluble, although not always. You may wind up with one solid reactant, sometimes even 2 solid reactants. Right? But the key thing here is that at least one of your products has to be a precipitate. It has to fall out of solution. Right, that's what a precipitate is. Now, again, solubility rules, you have to have them memorized. These are another one of those evergreen topics. I reserve the right to ask you solubility questions at any point in the year for a graded assignment, and you just have to know it. Right, solubility rules aren't that bad, so learn them as quickly as you can. So there are basically 2 ways you can go about writing a precipitation reaction. You have the long way, which is to start off by writing the molecular equation, turning it into the ionic, and then the net ionic. And then you have the short way, which is just using the solubility rules. Right, so I'll show you an example of each. So actually, before we start off, why don't you guys pause the video for a moment, try to write all 3 of these equations. All right, let's see what you get. So write the molecular equation, the ionic, and the net ionic for the reaction of lead nitrate with potassium iodide. Okay, so let's see how you guys did. Right, so our molecular equation, lead nitrate is PbNO3 2. Nitrates are aqueous regardless, so all nitrates are aqueous, plus potassium iodide. Potassium iodide is also aqueous. Right? We know potassium iodide is aqueous because group 1 metal potassium compounds are generally soluble, and most halides are soluble. Right? So we have these 2 compounds right here. They're going to react in their double replacement. We're going to get lead combining with iodide, so PbI2. Like I said, most halides are soluble. The exceptions for halides are heavy metals. Right? So lead is one of the heavy metals, so this halide is insoluble. And then we're also going to have potassium nitrate. Right, so KNO3, group 1 metal, nitrate, both of them are always soluble no matter what, so we're just going to mark this down as being soluble. Come back, balance the equation. And there's our molecular equation for the reaction between lead nitrate solution and potassium iodide. Right, from here we break it up into our ionic, so we're going to have Pb. Now, I'm not going to write states that matter for ionic equations. You typically don't have to do it unless you're asked. Right, so I'm just going to say Pb2 plus plus 2 NO3 minus. I apologize for the lines here. I probably have to fix the liftoff distance for my little tablet. Then we have 2 potassium ions. We have 2 iodide ions. That will form PbI2 plus 2 potassiums plus 2 nitrates. So that is, for lack of better handwriting, our complete ionic equation. And then we cancel out the spectator ions to get our net ionic equation of Pb2 plus 2I minus yields PbI2. Right, so this is our net ionic equation for this precipitation reaction. You mix these two solutions together, and all you see is the lead ions and iodide ions combine to form a lead iodide precipitate, which your sign of this reaction, not only does it form the precipitate, but this precipitate is actually very yellow. Right, so it'll form a very, very yellow precipitate. It'll look kind of like Big Bird in a beaker. Right, so that's the long way of doing it. So let's go over how to do it the quick way. Right, so the shortcut method. So I'm just going to write down my two reactants, right? So lead nitrate and then potassium iodide. Now here's what I'm going to do. I'm actually going to look at double replacement and see what's soluble, right? So here's what I know. I have lead ions, which can be soluble under rare occasion. I have nitrates that are always soluble, potassium that's always soluble, and iodide that's usually soluble but not always. If we were to do our double replacement, K would wind up with NO3, soluble with soluble. So that means I can immediately get rid of the K and the NO3 from my ionic equation because I know the product they're going to form is always soluble no matter what. Now I have to look at lead and iodide. Well, halides again are usually soluble unless it's a heavy metal, which lead counts as, right? So that means that we're going to have our lead ion reacting with iodide ions. Just put in the charges. Iodide is minus, lead is 2 plus. That will form lead iodide as a precipitate, so PbI2. And then I just go through and make sure I balance the equation for mass. And that is the ionic equation for this precipitate reaction, or precipitation reaction, right? This is the shortcut. If you know your solubility rules, you can just ignore things that are going to be soluble and focus on only those things that you know are definitely not soluble or may not be soluble. Right, so again, if you guys have any questions, make sure you bring them in the class and we will go over them.